Oh, hey, how's it going? Oh, I should have set this up earlier. So entire script. So what I'm gonna do now is record myself solving today's online assignment. Share, right? So I'm recording. Well, I am recording this. I'm presenting. Let me make sure everything's set up. And what this assignment is, we'll see in a second. I'm presenting. Everything's set, so I can go in. It's set up. Oh, I didn't even save it yet. You gotta save it. All right. So this activity was on ThatQuiz today, called CALC group activity. You guys were supposed to work on this together. I'm gonna put my solutions or my, actual video of how to solve that. So I'm gonna try to be pretty quick. All right, here we go. So use the graph of the following equations. Okay. Sorry, I had to read and I had to, my attention was somewhere else. All right, if applicable, use the following. Okay, so f of, I'm sorry, limit as x goes to 2 from the negative side. So here's the f function from negative side. So x goes from this direction. I'm writing this this curve here. What value am I approaching? What y value is 1. It doesn't matter that it's open circle. It is a 1. Now I'm doing the same thing, limit up this function, but I'm coming from it from the positive direction. So this is what I'm kind of following. So I'm coming, as x is going this direction, y's are going down, 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 and it looks like their destination is -6, even though it's an open circle. It's okay, -6. Now limit overall. This is really like a limit overall. This is a combination of a limit from negative side and limit from the positive side. If they come to the same destination, that would be a common limit. But in this case, the limit is definitely not common between them. So we say the limit does not exist. Think of it as the overall limit does not exist, because this guy is going to this location, +1, and this side of it goes to a negative location, -6. So it's we're using D and E, right? D and E. It doesn't matter if it's capitalized or not. And the actual value, f of 2, means the actual value of the function. What is the y value when I go to x2? Here is x equals 2. Where's the y value? Well, the y value is right here. And that is at 4. So the y value itself is a 4. But the limits are going somewhere else. And in fact, there is no overall limit. All right, next one. Okay, use the graph. Okay, so it's a similar kind of thing, but it's a different graph. Let's see what we have here. As going to 1 from positive direction. So here is 1, but now I'm sorry, from negative direction. So I'm going and following this curve. Well, clearly I'm going where? I am going there. Clearly this is an asymptote right here. So this is going to -infinity. And the word is, it's a negative I and f. So what I should be putting in, make sure, there's no symbol for infinity on the keyboard. So it's -I and f, negative-infinity. That's from the negative side. How about the positive side? So I'm writing this curve right here. Well, what y value it seems to be reaching? Well, it looks like it's going to reach -2. That's the y value, even though I have an open circle there, but that's really what the destination is. The y is -2 here. So what's the overall limit? Since there's no consensus between them, they're not in agreement, the limit does not, D and E, does not exist. And f at 1, well, the actual point is right there. That's the actual point. So it is, what does it look like? -8. Okay, next one. Okay. Analytically. All right, analytically means, well, can mean a couple of things. You're using a little bit of algebra to simplify things if need be. But in this particular case, this is a polynomial. In fact, if you recognize, this is just a parabola. with nothing else, there's no denominator. There's really nothing really difficult about this problem. There's nothing. There's no gaps. This is a very straightforward polynomials. It's so I'm going to plug in here and here. It's called direct evaluation or direct substitution. So what am I going to get? 9 plus 6 minus 5 looks like a positive 10. Okay, next. Analytically, same idea. I don't see anything complicated here. There's nothing to cancel. There's nothing to combine. So this is a direct substitution in here and in here. So 2 in here, that's an 8, right? 2 in here, it's a 6 plus 2, so that's 16. So this must be, oh, square root. Almost forgot. Oh, square root it. So this square root of 16 is 4. Right. So in fact, I'll do that. I'll demonstrate. So the whole thing goes in the square root. I almost forgot that. Okay. Easy to overlook. Okay, especially if you're not paying attention. All right. Oh, definitely more complicated. Now I have a rational something going on, meaning there's something above, some denominator. And what I notice immediately that there's a problem right there. If I plug 5 in here, it's going to give me a problem. Now, I anticipate that, if I plug 5 in here, it's going to give me a 0. It's going to give me 0 up top also. This looks like one of those 0 divided by 0 type of problems. But let's just verify it, because you can, if the numerator is not 0, then you just have an asymptote, and just all right. Let's plug 5 in here. 5 is 25. 25 plus 5 is 30. So this really becomes square root of 30 minus square root of 30, whatever that is. It's 0. And the denominator, we plug 5 in here, is 0 divided by 0. That's just like I anticipated. 0 is 0. So I'm going to erase this or drag it. Yeah, drag it. Okay, I'm going to drag it out here. So I need a little bit of space for the work. All right, so what technique am I going to use here? Well, normally, as soon as I see square roots, I am thinking I'm going to multiply by the conjugate. The conjugate here is that with a plus sign. So I'm going to multiply top and bottom by this nonsense. Square plus 5 minus square root of 30. Okay, top and bottom. So it's the same thing, x plus 5. Now, you technically, like you could do this in your head. You don't need to write this out, but since I can't videotape what's in my head, I'm writing this down. All right, so make sure you don't distribute this, because I anticipate this will cancel out. That's sort of one of the, that's definitely a goal. All right, so when I multiply this stuff out, this is a, I'm sorry, right, that was stupid. The conjugate is a plus here, sorry. This is on videotape, just rewind and, erase that part. All right, so when I multiply this, when I FOIL it, or just use the a squared minus b squared. So this really becomes down here, it's x squared plus 5, you can think of it in parentheses, minus 30, because when you square here, square root of 30 squared is just 30. So I don't really need those parentheses. Okay. Oh, let's see where this goes. This is not what I intend. Oh, yeah, I see it. All right. So x minus 5 here. And this nonsense, just kind of, I'm not even going to bother writing it. It's just this in here. Okay, I'll just put the word nonsense. Simplify up top. Well, I'm going to get x squared minus 25, right? So you open the parentheses, that's minus 25. And down here, I have, and I like this. I mean, I'm going to cancel something out. So after a little bit of factoring up top, this really becomes x minus 5, x plus 5. And now I'm going to write out the whole denominator, including the nonsense in here. X minus 5, And this is what's known as removable discontinuity, because we're about to cancel it and just remove it as if it wasn't there to begin with, even though it was. So what's going to be down here? That little thingy. So open the parentheses, open the parentheses, I'll close it. Square root x plus 5, so plus 5 plus square root of 30. That's ridiculous. All right, they're trying to trick us, but really it's okay. So this cancels, this cancels. Now you could plug in 5, because at this point I'm sure, right, we remove the discontinuity, and I'll use this marker right here. So I'm working back. I'm actually going to work here. So plug 5 in here. 5 plus 5. I'm going to write everything out. What's going to be inside here? Big root sign. This is 5. What? Okay. Now, why are they messing with us? This is what, 10? Square root of 10. And they're not combinable, but let's see where this goes. Square root of 10 plus square root of 30. So what is that? 10 divided by, well, this is really not combinable. I imagine you could also multiply by the conjugate again, but how's that going to help us? Up top, it's going to be a minus that. So I don't really see the answer unless that is the answer, none of these. Let me see if I'm brave enough to actually go on and go for that. Let me see if I messed up anything here. Oh my gosh, I'm so stupid back here. Yeah, that's what, a little negligence, a little overconfidence. So right, I wrote x squared plus 5. Here I did not write that, so that should be a plus, squared. It doesn't really change anything up until this moment right here, right? So this should be a square here. I'll actually use blue to indicate that really wasn't there begin. So what is this right now? Oh, okay, that makes it so much easier. All right, so much easier. Okay. Plug 5 in here. So the top is going to be 10, clearly, right? How about the denominator? Well, 5 in here is 25 plus 5 square root of 30. So it's square root of 30 plus, well, another square root of 30. All right. So that's 2 times square root of 30. But you have a 10 up top. So this really becomes 5 divided by square root of 30. And I bet you they're going to expect me to rationalize it. Now, why would I do that? I still don't see the answer. Square root of 30. So, oh man. Okay. So I'm gonna do my work over here. This is not a pleasant problem. All right. So square root of 30. So this becomes 5 times square root of 30 divided by square root by 30, and that simplifies to be what? Right there. Right there. Now, if this was not on videotape, I'd curse them out right now, but I'm not going to. All right. Part of it was definitely my fault that I was neglectful and I forgot to put a square here, and but I realized that right away. I mean, I shouldn't say right away. I realized that the answers don't make sense, and I fixed it. All right, moving on. Find the limit analytically. State the actual number and the positive signs. It's not exist. Okay. So immediately when I look at that, I'm anticipating a jump. There's got to there's a very strong possibility of a jump discontinuity, because when it's defined in chunks, defined in pieces, that's why it's called piecewise function. It's very possible like something happens at this location. This is at x equals 2, something happens, 1, 2, something drastic happens. Like maybe on this side, it's this, up to this point, it's this, And from here on, it's something else, or actually that's a filled-in circle because that's a rule 1 is the one that owns that. And down here, it could be something else. So it could be, you know, over here, open, something like that. So I anticipate that being a jump. The way for me to check is really to approach this limit. Well, for this case, I could literally plug into and figure out what that is. But from this direction, I'm saying, well, what am I approaching? And you literally, even though technically rule 2 does not own value x equals 2, but you plug it in, see if it really, if it did own it, would it really reach the same value between here and here? So I'm literally going to just plug in 2 in here. Plug in. Go ahead, plug in. So this becomes 5, right? 2 squared plus 1. And now if I plug 2 in here, what is that going to become? 4. So it's 3, right? Just 2, 4 3. So this part, the top part, is going to location here. So it's 1, 2. It's location up here. Let me erase that so that's not confusing where I came from. That was just me hypothetically talking. So in this particular case, this function, whatever, it's a parabola, right? Clearly it's going to go, okay. So it's going to be at here at 5, value 5. But this guy picks up and starts to at value 3, open circle, and he does whatever he does, he does blah, that kind of thing. And this is a blah like this, kind of with a parabola at 1. So you could actually kind of graph this out, kind of like this. And there's clearly a jump discontinuity. So what? Oh, it's very faint. So what is the limit? Well, the limit does not exist because from the negative side, it's approaching 5. From the positive side, it's approaching 3. So the limit is D and E, because that's really D and E. And name the type of discontinuity. Well, that's a jump. So letter J. Okay. All right, next one. Let's go, move quicker. Oh, justify mentally. I said, well, what's this? How do I write that down? Justify mentally. All right, so I have a limit of this, some undefined, some function as a pro. Well, I just checked this, that they're all approaching the same value C. Okay, good. And so this is a number. So the 3 functions, and they approach different things as they go towards letter C, as the plug-in is letter C. For the so all this is really just evaluate this. So this really becomes like more formally, this should really be 2 times limit as x goes to C of f of x plus limit as x goes to C of h of, and I would never be doing this if I wasn't, teaching this. I'll just do this mentally. This becomes a plug-in. What is this right here? Well, they told us outright in the condition what that is. The limit of it is, this right there is 2, f of x. And what about h of x? H of x is right here, it's 3. So it is, so it's 2 times 2 plus negative 3. And you evaluate that. So that's a 4. So I'm going to go out on a limb, and I'll say it's a 1. My answer is 1. Okay. All right. Just verify. Yeah, I think so. All right. Same. So nothing's different. Oh, except for, right. Gotcha. So there's got to be A, B, C, different versions of A, B, C, but the original functions are the same. All right. Same thing. So I literally, at this point, I'm going to create my rational expression. What's the limit of g of x? Well, g of x is this right there. Okay. 0. All right, that's nice. What about this other stuff? I just want to make sure, like right now, seeing a 0, I want to say the answer is 0, but as long as the denominator is not 0. But right now, I'm just going to check it. So f of x is 2 here, minus, that's a minus. And what's h of x? Well, h of x is -3. Be careful about that. In this case, it really doesn't matter that, that really turns positive. This is like 0/5. But in another case, if the denominator was not 0, be careful about the two minuses back to back. So here, the answer is 0/5 is still 0. Okay, as long as it's not 0/0, because that would be undefined. That would be intermediate form. But given a situation like this, where you're not given any, you just would not know how to simplify things, how to proceed. Anyway, so let's go with this. Same thing. It's just that it's different. All right, so let's go with very quickly. All right, so this is the f function is the limit is 2. H function is that, so it's plus -3. You could have written just 2 minus 3. And the g function is, well, oh, okay, there it is. All right, in this case, it is -1 divided by 0. What does that mean? Well, this is an asymptote. This is not even a cancelable thing, so this is an asymptote, so it is d and e. D and e does not exist. You're not allowed to divide by 0. It's an asymptote. Okay. Oh, wait. Oh, okay. So that was C, and now it's part D. All right. So here we go. So very quickly. So this is all linear. There's nothing divide, but you don't divide, and so that makes it easy. That's really just 2 plus what's G? G 0, and then minus. Be careful. Oh, they're trying to trip us up. Minus -3. So the answer is 5. Okay, the answer is, right, the answer is 5 in here. Okay, next. With number 14, we're not a bad pace. Okay, all right, let's see. Evaluate the following limits. Yeah, okay. So the first thing I want to do is evaluate, plug in here, and plug in here. Well, we got a problem right here. So if I just strictly plug in, I'm going to get 3. I'm sorry, I'm going to get 0, 3 times 0, minus 1/0, which is, 0 minus infinity. So I'm getting -infinity. So what kind of discontinuity is that? Well, it's an asymptote, right? I don't think there's anything I could do here to cancel out, to make a whole out of this. Yeah. On this, for sure, there's nothing I could do about it. There's nothing to cancel. There it is. It's just, so the answer there is name the type. Oh, let me answer this. So I would love to say, here's why you can't say -infinity, because from the left side and the right side, they're going to different places. Chances are, if I were to plot this, if I were to graph this, it might look like something like, I don't know, wherever that, something like this and like this. Therefore, something from here might be going to -infinity, something. So I'm not even going to bother with that, because it really depends on what side you're coming from. The point is, it's D and E. Yeah, if they said from a plus or minus side, I would have to analyze that a little more and just kind of come up with it, kind of like put some very, very small values and just get a feel for where it's going. But right now, it's not even, it's not an issue. Does not exist. The limit does not exist. It's an asymptote. That's why, right there, -8 over or minus 8 over x is an asymptote. So it is a asymptote. Another way you could have kind of reasoned this out, now to think about it, watch. So you might have said, well, let's combine them. Let's combine these two together. And you're going to get 3x, common denominator is x. So this is going to be 3x squared minus 8 over x. And I don't know why I do that. Let me make the lines a little longer. And there's absolutely nothing you can do here to cancel anything, to remove a discontinuity. So there, I know at 0 at x equals 0, we got a huge problem. We got an asymptote. If I wanted to find out what the x, intercepts are and have to solve this for, so there's actually going to be 2 of them. Yeah, so it's definitely more complicated than my initial, just a very quick, rough graph. So this will cross the x-axis twice. I will have, if the question asks for more analysis of the function, I would say, hey, there's going to be 2 zeros, because when you solve that for equal to 0, there's going to be positive square root and negative square root of 8 over 3. Okay, all right, big deal. So so there's going to be 2 x-intercepts, and what I just told you what they are, but there's also a asymptote. There is a huge problem with x equals 0. All right, so I'm not going to, there's no need to analyze it anymore. I answered the question. Let's go with, oh, wait, there's more here. Ooh, that's not looking pretty. It actually looks pretty easy. That looks really easy. All right, I should just skip it and just say it's trivial. All right, I won't. So here's the numerator. Here's the denominator. So let's get the common denominator in the numerator. So this really becomes h squared minus 1 divided by h squared. Hopefully you can see that. And here's my denominator. I'm going to use a different color. So let's put a, why did you do that? Okay. So let me erase this part. I just want to just put a different color in here. So that's my numerator. My denominator is, well, it's the common denominator here. Common denominator of the denominator is still h squared plus 1. All right, divided by h squared. I want to leave this little box because I see that's the answer box. I don't know if you can see that. So what happens here? Well, this is a complex fraction. Let me use green. I can come immediately, well, hopefully you have the skills to just look at it and say, these guys will cancel. Well, just automatically cancel. So the answer to this becomes, x squared minus 1, x squared plus 1. And let's see if as h go, oh, well, x. Did I say x? I meant h. I'm right. As h goes to 0. Well, as h goes to 0, there's no problem here. There's absolutely no problem. So this will, yeah. So this, put a 0 plus 1, and this is 0 minus 1. What's the answer? -1 is the answer. Okay. So the answer there is -1, even though it looks like a horrible problem. And what kind of discontinuity? I'm almost tempted to say there is no discontinuity, but there is. Here's why. If this is what you started from, if this was the original problem, you say, no, this is not discontinuous. This is absolutely continuous. There's no problem in the denominator anywhere. But the problem is that's not what you started with. If you started here, you would say it's continuous everywhere. The fact that we started here with this ugliness, and we were able to cancel the problem that gave us trouble. What does that mean? What did we just cancel? We removed a discontinuity, because the original problem, if I put a 0 in here, well, I can't have 1 divided by 0. That would be that would be infinity. So the point is, this is a whole. I was able to cancel out the whole. So this is a h here, whole. It's a removable discontinuity. Removable ones are the ones you could cancel. There's, anyway, next. We kind of slowed down on that slide. That took a long time. Value the following. All right, so let's see. We validate the following limit. Okay, so immediately I know that there's some kind of discontinuity when h approaches 0, because right there, I have 1 divided by 0. I got a problem there. So let's see if we could actually cancel it, or let's see what we can do with it. Well, I want to distribute immediately. So this really equals to here. So this becomes 3h squared, that's a square, and minus h squared over h squared. Of course, what happens with the h squared? So this becomes 3h squared minus 1. And now we've removed the trouble spot. You know, the h squared is no longer at the bottom. I have no denominator, in fact. Right? I want to make sure. Yeah, I don't have a denominator. So plug in 0. Plug 0. What's the value? What's the answer? The limit is -1. Plug 0 in, evaluate. There is my limit. Therefore, the fact that I was able to cancel stuff when I distributed, I did a little bit of algebra. What does that mean? What kind of discontinuity? It is a hole again. It's removable. All right, next. Oh, wait. Was there another? Yeah, there was one down here. There's 2 per slide. Okay. So immediately I'm going to plug this in mentally. 0, 0. Okay, I got a problem. Let's see. I also noticed that there were common denominator between both of them, so it's the same one. So I'm going to rewrite this as, looks like x plus 8, x plus 2 here. What can I cancel here? Oh, yeah, I'm going to go do this. Right? Yay! And this becomes, yay, that's 4. You better not do that. If you do that, I'm gonna, I don't know what I'll do, but it's not gonna be pretty. All right, so back up. Okay. So this is what you have. You cannot cancel those x's. You can't cancel across a plus sign. Think of it this way. This is really like x plus 8. And I don't know why I'm telling you this. This is your calc. You know, you should know better. So x plus 2. You're not allowed to cancel anything like this, right? So anyway, so there's nothing I can do here. So what does that mean? What's my limit as x goes to -2? Well, it doesn't exist. It's undefined. In fact, I'm like 100% sure. Actually, I don't want to say that until I would graph it. Yeah, it's definitely asymptotic. So I'm going to say immediately D and E does not exist. Oh, it's right here. D and E, wrong box. Oh, that would have been, if I were to do that on a computer, I would get both of those answers wrong, even though I figured this out. And this is an asymptote. So it's definitely an asymptote because there's nothing I can do. I can't cancel it. It is definitely not a jump. It's not a piecewise defined function. This is a rational function. It's continuous everywhere except for with the denominator 0. So, all right, next one. And there's no more on this page. All right, how are we doing time-wise? I don't know. Got to go. I value the following. If the limit does not exist, state justify mentally. Okay. All right. Easy enough. So immediately you plug in. There's a problem in the denominator, right? It's a 0. And in fact, if you plug in 5 in here, what's gonna happen here? Well, it's going to be 10 minus 10, and so this is 0 over 0. So what do you know immediately? Indeterminate form. Therefore, you should be able to do something. You should be able to, use your algebra skills. In this case, it's a really easy one. You can see factor out a common 2. So this is really 2x minus 5. The whole thing divided by, x minus 5. Oh, this is too easy. So what happens here? Okay, that cancels. We just canceled a discontinuity. So what's the limit? As x goes to 5, the limit is, well, plug in 5. Where? There's nowhere to plug it in. So the answer is 2. The limit is 2 since once it's simplified, the answer is 2. There's nowhere to plug in the value x. So this is 2. Okay. Now, what just happened? Well, I canceled the hole. I mean, there was a hole there. I canceled the value for it. Therefore, I removed that discontinuity by doing this. But original problem has it. Therefore, it is a, whole. Okay. Next down here. Plug in. Yeah, this is going to be a 0 clearly. I'm pretty sure if you plug 3 in here, it's going to be a 0. This is a 9. 9 minus 3 minus, it's a 9. So 0, 0. So I just had to verify that. So let's do some algebra. Well, inside here, they're being tricky. Inside here, let's do that first. So this really becomes, you factor out and you factor that, and there is somebody on the outside. Okay, so let's do this. So factor it. Now, quickly, x, that's a -6, must be, and that's a negative, so it must be -3 and plus 2, right? Just verify, always verify at the end, because sometimes, in haste of things, you can, do crazy things. Yeah. So also another clue is, hey, I'm looking to cancel stuff with the bottom here. So this is x minus 3. I'm going to put this in parentheses only for emphasis. You don't need to put that. Here's the problem. Make sure you don't do something like this. Don't cancel this against this, because that 2 on the outside is going to trip you up. That 2 distributes first before you could cancel. So this really becomes x minus 3 squared, and this becomes x plus 2 squared. But we're interested in, x minus 3. In fact, I think this is very similar to the problem I showed in class today. Yeah, it is. So what happens here is this guy cancels with the group, okay? So he's gone. The denominator is nice and, gone. So what kind of discontinuity was this? The fact that I was able to cancel it, it's gone. It is a whole. I think the example I showed in class is where it was just the opposite, where it was canceled from the numerator, but the denominator stayed there. So it kind of looked like a whole, but because it stayed there, it actually was an asymptote. It was a double type of discontinuity. Anyway, so I canceled. What do I know? What do I know? Well, it's a whole. I already know this. Oh, I'm sorry. I didn't answer this. So plug 3 in here. Oh, that's interesting. What does it approach? The limit. It doesn't, right? So you plug 3 in here, it gives you 0. So this is a 0, right? Plug 3 in here. And 3 here really doesn't matter about, because that's a 5. That's, so I will. So it's 3 in here, it's 5 squared. And divided, there's nothing. So so the answer here is 0. It approaches 0. And it was a whole of a discontinuity. Man, that was a whole. All right. CALC. All right. Why am I reading that? All right, here we go. All right. I see. Okay, again, I'm sure you've plugged 3 in. Plug 9 in here. Square root of 9 is 3. 3 minus, that's a 0. Plug 9 is 0. So it's 0 over 0. So immediately, your eye should be trained to these things already. This is going to be something where I could cancel out. This is going to be a whole by doing what operation? I'm going to skip. By multiplying top and bottom by the conjugate. So square root of x plus 3, square root of x plus 3. Make sure I didn't forget anything. Oh, I'm recording. I'm not tutoring. I need to do this. Sorry.
You need to utilize the weather. Do that at night.
All right. Okay. All right. So, sorry. Here we go. Multiply. Multiply the bottom. So this becomes, this squared becomes, I'll just do this over here. This squared becomes x. This squared becomes my 9. Okay, there it is. Okay. Now, what about up top? Make sure you don't distribute this because this is the goal of this really was to cancel this. And this is really square. I went too far. Okay, that threw me off. Being yelled at's not good. Okay, so this is parenthesis x plus 3. Okay. And I'm canceling this against this. Now this simplified just to this. And now plug in 9. So plug 9 in here. 9. So that's a 3. Oh, that's a 6. Overall, that's going to be a 6. Let's just verify that. That's a 3 plus. Yeah. And because we were able to cancel this discontinuity, it is a whole. So it's a whole. Okay, next. Next, let's go. Oh, okay, there's more. All right. Oh, that's okay. But from the positive side, let's see what that does for us. Because immediately I want to see, well, do I want to multiply this out? I don't need to multiply it out. So because of the positive thing right here, it's telling me from the positive direction. So I'm going to plug in a very, very small number just to see where the whole thing is going towards. Well, before I do that, let me see if this is going to go to you know what? Intuitively, I think I will carry through the operations just to verify. Is that going to be? Yeah, I think I want to do that. So I'm going to multiply top and bottom by with a plus there. All right, so this is x minus 3. I'm going to multiply top and bottom. So this is going to be x squared minus 9. And I'm going to multiply it by... Oh, that's interesting. No, I don't want to do that. I'm going to multiply. This is like rationalizing denominator. That's really what this is. If I'm going to rationalize denominator, I'm going to multiply by in this case, the same thing. X squared minus 9, x squared. Oh, they are tricky. All right. So let's see what happens down here. Well, down here, it's really easy. It is simply, square root of anything times square root of the same thing is just whatever's inside drops out. So this becomes x squared minus 9. Okay, that's the bottom part. That's the denominator. Again, when this really is the same thing here, and you're multiplying, this, so the square roots kind of, whatever. I don't want to get into that. It's an Algebra 2 topic. So what about up top? I have x minus 3. And this kind of horrible thing, square root of x squared minus 9. Oh, yeah, I'm good. I'm good so far. So this is going to be, in fact, you could mentally factor it like this, or on paper, x plus 3, and I'm going to cancel this along with this guy. So my overall answer, this really became this. My overall answer is big root sign x squared minus 9. And this is x plus 3. Okay, that's what it became. Now I'm going to plug in a value very, very small, very close to 3, just to get a feel for it. And the reason why I didn't want to do it earlier, I could not have done it early because I'm going to get 0 down here still. I would get closer and closer to 0, which really, I can't determine how things are when you divide by 0. They go to infinity. The question is how quick. All right, now plug in very, very small number. So like 3.001. Well, when you plug 3 points, like let's say 3.001 plus 3. Well, the denominator is going to be 6.001. That. What about the numerator? Well, 3.001 times itself will be very, very close to 9. So this is going to be like 9.000 something, 1 approximate minus 9. So this is going to be very, very close to 0. But when you take a square root of it, it still stays as 0. 0 divided by 6 is 0. I'm going to go and say 0. Yeah, that's what I'm going with. Okay, and what kind of oh, it did not ask me what kind of discontinuity. Okay, so I guess when I made this test, I forgot to put that question in there. Question, well, what kind of discontinuity would that be at? Yeah, it would be a hole because I'm able to, like what I did was I was able to cancel. I was able to manipulate and remove that discontinuity. Okay. Yeah, my denominator was fine. All right, here we go. Here we go. Here we go. Let's go. That's the last. Yeah, that's okay. Oh, we gotta hurry up. Okay. I'm sure if I plug this in, it's going to be 0 because this is going to be 0 here. Yeah, this is going to be 0 over 0. I don't have to even check that. Immediately should be thinking factoring. So let's factor the top, x minus 3, x plus 3. Immediately, denominator is, oh, good, factor. So it's a 9. So it looks like it's, oh, it's a special case. So this is x minus 3, x minus 3. And the way I check it right away, first and last, they're perfect squares. The middle is negative, negative 2ab. Okay, so that's what it factored to. Now, cancel the first set of parentheses. What you have left over here is that. Okay, now what? I see the answer. Now what? Were you able to cancel out the discontinuity? No, the problem is I have two. I mean, at the same location, I have really, it's x squared. I mean, it's parenthesis being squared, so I cancel one of them, but the other one's still giving us a problem. This is still all right. So this problem is just like the one we did in class, the one I showed you, and I called it a tricky problem, because even though I canceled out part of it, but the other part I'm not able to cancel. So this is D and E does not exist. There's no limit to it. When you plug 3 in here, it's a 0. And it is an asymptote. So the type, location. Oh, what am I asking here? I don't remember doing this problem. I mean, I don't remember designing this. Okay. So what are my points of discontinuity? Well, x equals 3. But it's the same one. I mean, I don't recall. I don't recall what I put in here. I think you have to either leave it alone, or I don't remember what you have to put in. And it is in this case. Oh, you know what? I bet you. Did I? Yeah, I factored correctly. Okay. I think when I was designing this, either I mentally did something wrong here. I thought there might be two separate points of discontinuity, but no, there's only one point. One of them canceled, but the other one is in the same location, and it is an asymptote. So I don't really care. I mean, I don't know how I answer this in the on that quiz, but at 3, I'm actually going to go on the limb and say it is a asymptote. Okay, and this one I'm going to leave alone because I can't really say at 3 it's a hole, even though I canceled it, because at that same location, the asymptote is really, takes over. There is no hole in there, because as soon as I see the word hole, I'm imagining, two branches going to the same location. They just can't touch. So I'm going to leave it alone. I don't know what actually I put as an answer. It'd be nice to find out. All right. Very quickly. Here we go. Same thing. So there's no other. Okay, it makes it a little easier right away. Factor x minus 2 x squared plus, so this becomes really x minus 2. So okay, so that's a plus, by the way. You can't really see that. It's a plus. This multiply them out, so this becomes 2x plus 4, the whole thing divided by x minus 2, x plus 2. So simplify, boom, boom. Now plug 2 in here. So this at the bottom becomes a 4, right? Plug 2 in here, and plug 2 in here and here. once you're simplified. So this becomes a, let me see, I'm not doing this in my mind. So this is 4, that's a plus, it's a 4 plus 4. Oh, it looks like a, oh, they just cancel, right? Right, they just cancel, right? Oh yeah, sure. Better than that. All right, so what's up top is 12 divided by 4 is 3. So I'm getting 3 as my final answer. Okay. That looks fine. Looks fine. Yeah. What kind of discontinuity? This was a hole. We were able to cancel the bad locate. One of the, there's still a, right there, there is still a, at x equals -2, there is still a an asymptote which we were not able to cancel, but the hole we were able to cancel. All right, next one. Oh, wait. Anything? Oh, what's this? Oh, that's the one I just did. Okay. All right, so that's the one I just did. All right, here we go. So, oh, okay. Almost instantly, the answer is 4/5. Almost instantly. Now, you could go through all the steps why that is the case, but really, at the end, you could sort of train your eye to see the answer is going to be 4 divided by 5. And the way to think of it is really, where I'm thinking of is sine of something divided by it's got to be the same thing. If it's got to be the same angle in here and here, and the limit as x goes to 0 of this is 1. Okay, so and whatever's down here, if it has to be like a 0, overall value of it 0. Anyway, so the way to think of this is really sine, split them apart, kind of like this. Think of it, split them apart. And between them is multiplication, kind of like there's an invisible 1 here, there's an invisible 1 here. What does this guy need to kind of complete that? It's the Squeeze Theorem, actually. So this guy needs 4x. And then this way it's going to be equals to 1. Well, this one needs 5x. We can't just randomly put that in there and say, hey, that we're done. We're just going to have to like adjust for it by, well, we brought in a fictitious 5x, so I'm going to 5x down here. They're going to cancel each other out, kind of. And same thing here, 4x. And now this part right here equals to 1, so I can ignore it. This part right here equals to 1. I could ignore it. So what do you have left over? Well, you have 4x over 5x. And of course, x's are allowed to cancel because they're not 0 themselves. They're just going toward, I mean, they just cancel. All right, forget what I was about to say. The answer here, the limit is 4 divided by 5. Now, you can do this enough times where you recognize, hey, the answer is instantly that ratio. Technically, you really should go through this to verify, because I could design a problem where I'll do something with it, and that very quick approach will fail. But the answer here is straightforward: 4 divided by 5. Okay. Okay. Now you might be tempted to hold on. Let me think. Oh, I see it. Yeah, you might be you might be tempted to split them apart. Maybe. I would do the following. I would see a common factor between them. I'm going to do this. I'm going to pull x out, but I'm actually going to leave it behind. So this really becomes x minus 2. Normally, when you do a common factor, you pull it in the front, but here I'm actually doing I could have done in the front. You know what? Let's not complicate your life. It's complicated enough. So the normal way, right? So here we go. This is really just x minus 2, normally. And this is sine of 3x. I'm just going to, And I'm going to, sort of push in this to kind of focus your attention. Well, what does this value need? What should be in front of this x to kind of make that into what you want to recognize it as, the limit? Well, it really needs to have a 3 here. So if I multiply the top by 3 and the bottom by 3, and I'm going to multiply the bottom by 3 out here just to show you, that right there, that's 1. The answer to this, what's circled here, is the limit of that is 1. So what I have here is x minus 2, which this I don't need to write. And down here I write it's 3. Okay. So that's what the limits simplify to be. Now let's plug 0 in. Literally just plug 0 in. You're going to get what? Well, negative 2/3. Okay. You can obviously could pause and just think about it, reflect on it. Okay, but yeah, that's the answer. All right, let me see. That's the last of that slide. Let's see. Is that last? Okay. Oh, I don't want to do these problems. Oh, that's ugly. Okay. So when I look at this problem, I realize, hey, it's kind of ugly. But what you should be reminded of is this 1 minus cosine of x, and this is x, and the limit of this, limit as x goes to 0 is 0. Okay. All right, so how can I get something, how can I rearrange this to kind of get this? And again, notice, even though it's written as an x, they have to be the same. Whatever this angle is, it has to be the same angle here. Okay. Whatever this angle is here, the value of, because you're taking cosine of an angle, and this is a same numeric value, even though it's not truly an angle down here. Sorry, I kind of misspoke. All right, let's see. Let's see how I can manipulate this. Well, one part is really easy. Lola, stop. Oh man, there's somebody walking in the front again with a dog. All right, I just need a 4 down here. Oh yeah, that's kind of easy. Ooh. You know what? The funny thing is about this skill, there's such an easy way of doing this with a skill that you will see in a next chapter, or it's a well, I don't want to preview it too much, but it's like this is a 10-second problem, maybe less, and it's guaranteed to be correct. Whereas now with algebraic manipulation, it's definitely a little tedious. All right, so I'm going to do this. I said 1 minus cosine of 4x. I need 4x down here. So I need 4x down here. Well, out of this, I have an extra x over here. I need to bring in a 4 up above. You see where hopefully you see where, because that 4 wasn't there to begin with. So basically, I multiply top and bottom by 4. And I have a 9. So all of this could be rewritten as that, and it has the same algebraic value. Let's just kind of go through it again. I didn't change this. I'm focusing on the 4. And I say, well, if I multiply the top and bottom by 4, I'm not changing anything. And the reason I'd like to multiply it by 4 is really just to get and basically I split this up as 9 times x times x. And the 4 will combine with this x, and there it is. And again, the reason why I want to do that is I want to match up my angle to this value. So what's left? So this right there, the limit of all of this part right there, the limit of that is 1. Okay? Now, I don't like the fact that there's an x here, but I don't think I can do anything with that. So when I plug 0 in, that's going to make it undefined. So even though this is 0, ooh, now there should be something. You know what? Oh my God, no. Chances I'm not going to do this right now. Here's the problem. When I plug in 0 in here, this is 0. So this is, all of that is 0. What about, so it's 4 times 0, and at the bottom I have 9 times 0. I'm thinking this is 0 over 0 in indeterminate form, so there's something I should be able to do here. What comes to mind, and I don't like it, I don't think that's the case here. It would be doing some kind of trigonometric substitution here. If fool around with this, looks like a double angle. Maybe use double angle identity there, which I really don't want to. Yeah, I don't want to do that. Let me just verify if this problem is of the type that requires that, some really high, not high end, but just kind of, because I'm looking at that might be a double angle identity, maybe even twice. I bet you it is. Well, I really don't want to do that, because I'm going to show you later, like not today or tomorrow, but a skill that I'm actually going to employ right now to see if I can come up with an answer. It's called L'Hopital, even though it's really not part of algebra. I mean, it's not part of our chapter on limits, everything that we've done so far. But later on, you'll learn the skill. And so let me just kind of quickly go through this. So this is going to be what? 18x. This is going to be sine 4x times 4, right? So plug 0 in, it's still a problem. Let's do it again. So this is 18. This is going to be cosine. So cosine of 16. 16. Yeah, I think so. 16 cosine 4x. Cosine 4x, that's positive. I just want, yeah. All right, so now plug 0 in. This becomes cosine, that's 1, so it's 16 over 18. So I am getting whatever this is. So divide that by what? By 2, so it's 8 over 9. I wonder if that's, I mean, I'm going to check whether that's the answer. That's not something I would expect for you to come up with. In fact, how long did it take me? In I don't know, 15, 20 seconds maybe. And even because I was a little disturbed to see some numbers here, anyway. Yeah, I think that is the answer. I would verify it in a different method, but right now I'm going to leave it alone, because I really definitely did not expect for you to do that problem. I snuck in there. I did not teach that technique, nor did I teach using trigonometry here. Yeah, I think I bet you that's without the skill, the technique I just did in my head very quickly. This is a trigonometric substitution of some kind. I did double angle identities and so forth. Really not worth it. Same here. We don't know from algebra. From this particular chapter, any identities that require tangent. So I would maybe split this up into sine divided by cosine and do something with it, or use L'Hopital's rule, which is a chapter 2 or 3, I forget which one, chapter 2 skill. So you haven't learned it yet. Once we get there, I will teach it to you, and it'll make so much, your life so much easier. Anyway, so I definitely, I'm not going to do this now, and definitely I would not expect for you to do this problem now, not at our level anyway. Let's see what this. Oh man, more. Is this last? Okay. Oh, okay. We're at last problem. Last problem. Let's see. I better step up and do something with it. Looks like a plus. Yeah, it looks like a difference quotient. Yeah, definition. Yeah, okay. Next chapter, we'll see a lot of these problems, unfortunately. Well, at least we'll see the easier version of this. Let's see, how am I going to do this here? Again, immediately what comes to mind is a rule that you guys are not familiar with, L'Hopital's rule, that I would say solve this in a matter of maybe a couple more seconds because of this situation. Probably not, but definitely less than a minute. I'm thinking maybe 30 seconds or so. But in this case, you're not allowed to use L'Hopital's rule. So hopefully this chapter, wherever I got this test from, doesn't rely strictly on L'Hopital's rule. So how would I do this? Oh, I see it. Okay, I see it. A little bit of a tedious problem. It relies on sum of angles identity from your trig days, from your pre-calc days. And I realize pre-calc may not be as strong. You may not be as strong with it because of last year's corona closure. But this to me looks like so I know I'm going to be sooner or later probably canceling with this. But right now that looks like a sum, a cosine of a sum. There's two angles here and here. Yeah. So let me try to recall what that is. All right. So it goes something like cosine of A plus B. Doesn't matter what letters I use. It could be X plus Y. It depends on your teacher. So cosine, if I recall, I think it's, yeah. Cosine of A times cosine of B minus, there's a minus sine of A sine of B. Yeah, I think so. Okay. So if you remember this formula, if you remember this formula, well, that's what you have to use here. Again, eventually I'll show you a way to get around this, but in this particular case, you have to use that. I mean, I'm sure, because that there's no other way for me to deal with this. So that's this. So I'm going to follow with, so this really becomes the following. I'm going to try to wedge my work in here. Cosine of pi over 3 times cosine of h. Okay, that's that. Minus sine of pi over 3 times sine of h. Now that's just this part. What about this other business right there? Well, that's minus, oh, I see where I'm going with it. Cosine of, let me just bring this out. I needed more space. Minus cosine of what? Cosine of h. I didn't even get a chance to write it. Cosine of h. Okay. Wow. And the whole thing is divided by, that's just my numerator. The whole thing is divided by h. Okay, I'm just going to write h in here somewhere. Now, nothing really cancels. You can't just cancel it. Oh, there's no h's, as a coefficient. You absolutely can't cancel this h and somehow. Oh, they all have letter h in them. You absolutely can't cancel that. They're inside. This is an argument for an operation. All right. Gotcha. I see it. Oh, they're sneaky here. This is definitely a tough problem. Here we go. I see it. I'm gonna combine this. Not cancel. I really can't cancel. They don't cancel. I'm gonna combine them. That's my common, yes, my common factor. So I'm gonna cancel out this. Oh no, I made a mistake. No wonder. Yeah, because I'm like, I don't know where I'm going with this. No, it's the wrong, right. So yeah, right there, it's pi over 3. Okay, sorry, pi over 3. And that still is common factor. There it is. Now I see it. I absolutely see it. There's a common factor between both of them. So I'm actually going to factor out the negative version of it here. So this is what it's going to be. Negative cosine of pi over 3. I'm going to put this in. This becomes a 1, right? This is a 1 minus cosine of h. Oh, I like that. Okay, I see where I'm going with this. I really should have made, you know what? Let me do this. I apologize. Let me make space. Unlock and make this much smaller because we don't need for it to be that big. But that gives me space to write. Okay. Okay. All right. So okay, I see where I'm going with it. And so that was a combination of this and this. So I still have this business right here. Minus yep, see it. Minus this is a little, it will be so much better with with more space. Pi over 3 times sine of h. And the whole thing, I'm going to split this h into 2 parts. I'm going to put it right here and right there. And I don't know whether you see it or not yet, but I see something way here. What is this right here? That. What it says is sine of h divided by h. What's in front of it is this negative, well, it's in front of negative sine of pi over 3. Now, don't be confused by pi over 3, sine pi. That's just a number. That's just a pure number. This part, on the other hand, is what? The limit of that equals to 1. That's one of the things you are responsible for. That's absolutely something you need to remember. So that's why I didn't really go over it at the beginning. But anyway, and what's this right here? What is this right here? That's another thing you're responsible for. That equals to 0. Well, that's nice because it doesn't matter what this. Well, this is just a number. It's you remember what this is. Cosine of pi over 3 is 1/2, so it's negative 1/2, but it's times 0, therefore it's 0. So the answer here simplifies 0 minus, this is a 1, so it's a minus sine of pi over 3. Let's try to remember what pi over, so sine of pi over 3, well, pi over 3 is 60, right? So sine is, so this is negative square root of 3 divided by 2. This is the answer I think it, this is what I think it is. Hopefully it's there, so I'll just verify that. So it looks like it's D. That's what that's what I'm getting. I think it's D. Now, I would love, I shouldn't say I'd love to, I really should go through just to verify. But I like this, and yeah, and my answer is right there. So I'm going to go with it. Whether I'm taking a slight chance by not checking my work. I really, on a hard problem, and this is a hard problem. On a hard problem, I definitely should check my work, but I'm going with letter D. Not willing to bet my life on it, but because they might have tried to mess with us by throwing us a little curve here with change of signs, plus or minus or something. Maybe it's none of, maybe it's, I don't like that. It's right there also. But I think it's, and this would be on a part of the test with no calculator, because otherwise you just put this in a calculator. It's very, very close values of 8, close to 0. You put those values in, and which one comes closest to one of the answers here. I'm going to close out here because this looks like the end, right? So I'm going to I'm going to put a stop put a stop to the recording, and hopefully this will be available online very, very shortly. So let me put a stop recording. Okay, bye.